Hi po. Out from the applications of the Pythagorean theorem on right triangles, we could come up with special relationships on two different special right triangles. The first one is covered by this video, and the last one will be covered by the next video soon. This first video is concerned on a triangle which has equal sides, equal legs rather, okay, equal legs, and we have here a 90-degree angle. This is the example, or this is actually an isosceles right triangle, okay, where isosceles being all the legs of the triangles, the legs of this triangle are equal, okay, and that would mean that the angles here, base angles, are also considered to be equal. That's why the other term for the isosceles right triangle theorem is that it's called to be 45 degree 90 triangle theorem. We could actually take the value of the sides of this triangle from the consideration of the Pythagorean theorem. Even if you're only given one side, just like in this example, we can solve for the remaining sides. Let's look at number one. A here is equal to 4. Okay? Since since A is equal to B in terms of its notation, and of course it's given to be an isosceles right triangle, if A is equal to 4, then B, by substitution property, B is also equal to 4. So I could write it here 4. Okay. Now, to solve for C, you could actually use the Pythagorean theorem here, okay, wherein C squared is equal to A squared plus B squared. Okay. Substitute the values for A, which is 4, and B, which is also 4. You would come up with 16 plus 16, which is 32. And then take the root of both sides is positive negative square root of 32, which is actually positive or negative square root of 16 times 2. Take out 16, you have positive negative 4 square root of 2, which could be trimmed down to a measurement, acceptable value for measurement, which is positive 4 square root of 2. You could always use the Pythagorean to solve for that. But since we already have the 45 90 angle theorem, we could automatically say that the measurement of side C is equal to A square root of 2 or B square root of 2. Either way, A and B are just the same. Therefore, C is just simply equal to 4 and then square root of 2. Because the isosceles right triangle theorem tells us that the measurement of the hypotenuse is the square 2, a square root of 2 times the measurement of any leg. So you may use the longer method here, or you may use simply the shortcut here. So you have 4 square root of 2. Applying the same concerns, so A is equal to B for number 2. So A must be equal to the value of B, which is 6 square root of 2. You have 6 square root of 2. And since we already have established that under Pythagorean theorem and the theorem of the isosceles right triangle, or the 45 90 right triangle theorem, we'll have the same result for the value of the hypotenuse. You don't need to use the Pythagorean theorem anymore. We all know that C could be either A square root of 2 or B square root of 2 because they have the same value. So let's use the value here. So you have for A is 6 square root of 2 times square root of 2. Not forget that the square root of 2 here is the multiplier to A. And since A already have a square root of 2, do not forget to multiply it to another square root of 2. That would mean this is 6 square root of 4. This is 6 square root of 4, which is 2. So the value for C is actually equal to 12. So the value of C is equal to 12. Notice that what happens here If the measurement of your legs are without radical expression, you would expect that the value for C has a radical expression. But if your um, legs contains radical expressions, specifically square root of 2, it could be removed when solving for C. So similarly for number 3, since the value of C is given to be 16, we expect that our A and B, being the same, will contain square root of 2 as a multiplier. Let's look at that. Since C is equal to A square root of 2 and C is 16, we can solve A by dividing both sides by square root of 2. And then we have A is equal to 16 over square root of 2. Rationalize it by multiplying square root of 2. So you have 16 square root of 2 over, take that of the denominator, that's square root of 4, which is just equal to 2. And then further, A could be 16 divided by 2 as, yes, that's A. A is equal to 8 square root of 2. Again, since our C has no radical expression, our A will contain it. And since A is equal to B and A is 8 square root of 2, that is also the value for B. So B is 8 square root of 2. Now this is only unique for a 45, 45, 90 right triangle. It should be 45, 45, 90 right triangle, or also known as an isosceles right triangle. If it's not a 45, 45, 90 right triangle, then you may not use this shortcut, but rather you can still use the Pythagorean theorem. Our next video will be concerned on the next or the other special right triangle, so stay tuned for that. Goodbye.